Good evening all. So I am going to discussing about advanced communication systems. So before going to introduce myself, I need to tell about the subject. Okay. So what is syllabus present for the ESC? Totally divided into three parts, advanced communication system. So the first one is optical communication, second one is microwave communication, and the third one is the data communication system. So completely we are having three parts. So first of all we deal with the part 1. So in part 1 we study about the optical communication system. Okay. So we are studying about the optical communication system. This is the first part. So we see about the second part, that is called as microwave communication system. Microwave communication system. So there is some problem with the pen. So we can see in detail about these two parts first of all. Then I can start with the third part, that is data communication system. So before going to discuss about this one, I will tell the syllabus which is present for the engineering service exam and also for other PSUs also. So complete syllabus I am giving. So first optical communication system, we have introduction to the optical communication system. So why we are moving to the optical communication system, what are the reasons behind that. Second thing we discuss about the review of optics, the sum of the optics part we study in our plus 2. that too in our physics part of +2. So where we see about some of the review of optics we discuss here, which are very much important, that how light is passing into the optical fiber cable. So next we see about the third important part, that's the types of fibers. So what are the fibers and how they manufacture, on what basis we select a fiber, and what are the different types of fibers and how the light was passing through that fibers. Okay. So we can take the refractive indices of each and every fiber parts as core and claddie. After that we discuss about the next one, that is the fourth part, which is called as attenuation. Obviously you knows that for every transmission lines there are two things which are present. So one is called as the attenuation, and the signal is passing through a fiber or through a transmission line. The first thing that we can see is the attenuation, and the second most important thing that we can consider is as the noise. So whenever a signal is passing through any channel, irrespective of the type of a channel, is an electrical channel or it may be an optical channel, whatever it may be, the light is passing into the channel, the thing is it must definitely have a noise. So that noise is also be considered. So as we are studying about the communication systems, noise plays a very dominant role, and most of the students knows about that. Noise plays a very dominant role in communication systems. So without noise, we can tell very clearly there is no need of studying this entire communication system subjects. Okay. So to reducing that noise only, we are introducing so many number of modulation techniques, so many number of types of transmitters and receivers. So to make an impact of that noise to be less, overall noise to be less. And remember carefully, we never remove the noise, we always reduce the noise. That means the effect of noise will always be reduced. So that will be studied by us. So two things are very important if you talk about any channel. So here up to now in communication system, I think you study about your analog communication and digital communication system as an electrical channel. So what happened when an electrical signal passing through a channel? But right now we are studying about the same concept is same, but the thing is your carrier signal is changed right now, and your channel is also changed. Instead of electric channel, we are having dielectric nature, optical fiber cable we are having. That's it. The most important thing we need to observe between these two things is, on one hand we discuss about the communication topics, on the other hand we use them as advanced. So what are the advanced things that present in the communication system, we study in this one, but the basics are most important. That means the analog communication what we studied, the digital communication what we studied are required. So whenever we require those things, I will discuss them at the other end, we can discuss about them, right. So next part I need to discuss to you is the, after attenuation, we see about the light sources, what are the different types of light sources we are having, and next we see about what are the different types of so called your light detectors, that is photodetectors, and next we see about the design parameters. This is syllabus, complete syllabus. So here we are discussing about the syllabus which is mostly focused for the ESC and PSUs, and for ESC in the prelims part we are focusing, and for the PSUs, for the all PSUs, the syllabus will be discussed here. Okay. So next after that we see about the microwave communication. So I will add the syllabus here. So the first one is we discuss about the introduction. So we are discussing about the introduction part, as already told to you. So second one is review of optics. Review of optics. Third one we discuss about the types of fibers, what are the different types of fibers we are having. Types of fibers. And fourth one is attenuation. We will see about the different types of attenuations that offered in the fiber. which is denoted as alpha, attenuation is denoted by alpha. We study in the transmission lines also alpha plus j beta, where alpha is called attenuation and beta is called as propagation constant. So that's when the wave is propagating, we have the propagation constant also considered. So next one, that is the point number 5. We see about the what are the different types of light sources we are having. So that is LED and a laser, the two different light sources. And the sixth one is light detectors. Your light detectors is also called as photodetector, which is called as the light detectors we are having. So next one is we see about the seventh one, we discuss about the design parameters, that is link design. It's called a link design we are having. This is the syllabus which is present for the optical communication system. And now coming for the next one, which is called as microwave communication system. So here also we will discuss our introduction to the microwave communication system. So we see that why we are going for microwave communication system and what are the uses of microwave communication system. And next we can see that what are the frequencies that are present in microwave and what are the different types of components we use in microwave and how the microwave signal was generated by using the sources like klystron, magnetron or two cavity klystron. Like this we will study. And after that we discuss about the next important thing, the applications of this microwave communication system. So many students obviously knows about that. So we will see about the first major application that knows to many students in the class is about the cellular communication system. So we see about the cellular communication system. So after that we see about the wave propagation, how the wave is propagated into the free space and what are the different constraints that present when the wave is propagating into a free space. So we study about that. And next important after that we see about the another important thing is satellite communication system. Okay, so this is the syllabus which is present. Of course, radar is also there, but we can study that in the mains, not here. So that's about the syllabus. Radar is not present in the ESC. Sometimes they are asking the question also. In the mains, we will discuss about that radar part. Okay, so this is about the microwave communication system. So in microwave communication system also we will see first of all about the introduction. So introduction to the microwave communication system, why we are studying the microwave communication system, operating frequencies, operating components, microwave devices, and completely about the microwave generation, all these things. And second one is we see about the first application of the microwave communication system is cellular communication, which is called as the cellular communication system, one of the most important topic that present in the microwave communication system. Okay, which is called as cellular communication system we are having. So after the cellular communication system, we are discussing about the third important one, that is called wave propagation. So how the wave is propagating from one point to the another point in the free space, that is called wave propagation we are having. It is called as wave propagation. So in this wave propagation, after that we will study about the fourth one. After completion of wave propagation, we see about the microwave antennas, which is very, very important. The antennas that we are using at microwave communication is called as microwave antennas. So even though you study microwave antennas in your antennas, I can once again revise that because it's become very easy for us once we know about this microwave antenna operations. So we have three types of antennas. So if you study those three types, it becomes quite easier such that how this signal is propagating in the microwave frequencies from one point to the another point through a free space. So free space means the free space acts as a channel, unguided communication system. Okay. So next important one, the fifth one is satellite communication. It's also very important for your all competitive exams. So not in the GATE, but remaining all PSUs and ESC remaining all, it is very, very important, the satellite communication system we are having. which is called as satellite communication. So this is completely the syllabus which we are having for the microwave communication system. Already I told to you starting of the class itself only, we are having 3 parts. Part 1 is optical communication system, part 2 is microwave communication system. So this is the syllabus. So I am not writing the individual components or individual topics that are present in the each one, because cellular communication there are so many number of topics are there: introduction, handoffing, cell splitting, roaming, what is called as sectorization, okay, handoffing. So all those things we will discuss. GSM, CDMA, so different types of codes, how they show impact on the transmission, and all these things we will discuss in the cellular communication. Okay, so that's your second topic, which is a very important topic for the competitive exams and as well as PSUs, or if you go for any interview also, they will ask commonly some questions from these topics. Okay, so wave propagation and micro antennas is antenna topics actually. So we will discuss about here clearly about how the propagation is done in the free space. I hope many students will understand the difference between this optical communication and microwave communication system. I think you just revise your types of channels, what we study in the communication system. So we study about the 2 types of channels. I hope you remember that the 2 types of channels. The first channel is called as guided channel. So guided channel in the sense means where we have a physical connection between our transmitter and our receiver. Your transmitter and receiver are connected through each other by a line, by a transmission line, or by a channel. We call it as a channel. We don't call it transmission line. In EMTL, we call it as transmission line, but in communication systems, we completely call it as your channel. So if you talk about that channel, there are 2 types of channels. Already I told you, the first channel is called as guided channel. The second channel is called as unguided channel. If you observe carefully one thing here, whatever the optical communication system is deals with the guided channel. It deals with the guided channel. And if you see here, cellular communication system which deals with both guided as well as unguided. See, from your mobile to the cell phone tower up to that, because we are using a simple language, you go for technical language and you go into the subject. I am using a simple language to understand. Okay. If you use your mobile and if you see that from your mobile to the cell tower or the mobile tower, what you are having is completely wireless. There is no connection between that. Okay, there is no connection between them. But from cell phone tower to the remaining entire connection is purely connected by the optical fiber cable. It's an optical fiber cable connection has to be present between them. So understand such that it's having 2 hybrid modalities which consists of both your guided as well as unguided. So what's unguided? Unguided means there is no connection between your transmitter and receiver. Example, free space. I hope you studied this in your communication systems. So I think this is going to be the thing that you must understand clearly. If you have any doubt, I can explain, no problem. That is what the channel we are having. I can write that also. So even though some of the students may not be complete the communication system, it is going to be useful to you while writing that topic. So if you talk about a channel, so your channel is of 2 types we are having. So the first one is called as guided channel. The meaning of guided channel means physical connection between transmitter and receiver. And the second one is called as unguided channel we are having, which is called as unguided channel is present. So if you see about the guided channel and unguided channel, there are 2 types. So we have, so if I talk about the first one, so physical connection has to be present. So there is a physical connection is present between them. If you see that it's a transmitter, just to try to understand this part, it's a transmitter and it is a receiver. So any communication system will consist of 2 blocks, that is called as transmitter and receiving system, and another block is also there which is called as channel. It's called channel. Another name for channel is also called as medium. It's a channel or a medium. See, there is a connection, there is a physical connection between transmitter and receiver. So when we have a physical connection between transmitter and receiver, that is called guided. Why it is called guided? The wave is The electromagnetic wave is guided in between this to pass from transmitter to the receiver. It moves from transmitter to the receiver, which is called guided. What are the best examples of such type of guided channels? The best examples of such guided channels, I am giving the examples of the guided channels. So, those students which batches or those students who are not completed in the communication systems, it will going to be useful for you. Okay. Now, see here, the first important thing that I can tell to you here is, it is called as a copper channel. It is called as copper channel we are having. Second one is called as coaxial cable. It is a coaxial cable we have. It is a coaxial cable. And the third important one is called as waveguides. It is called waveguides. So, these three types of transmission lines you studied in EMTL, electromagnetic and transmission lines. So, what are the copper line? So, two lines are considered copper lines, and that is the copper line coaxial line. So, inner cable and outer cable has to be present. That is called as coaxial cable. And the next one is called waveguides. Obviously, students knows about the waveguides also. And the fourth one is called as OFC, optical fiber cable. This is what we are discussing in the classroom. Remaining all transmission lines and remaining all the concepts that are completed in the communication. That's what I am just revising that once again. So, if anybody has a doubt regarding that, you can please ask it. I can explain in detail to you. Okay. So, these, just observe carefully, these three cables or three channels are capable to carry your electrical signals. They are capable to carry the electrical signals. Okay, electrical signals. But if you talk about the OFC, optical fiber cable, they are capable to carry the light signals. They are capable to carry the light signals. Okay, so light signals will be carried by them. So, that is why OFC is mainly deals with the optical fiber cables, which will carry the light signals through it. Okay, so they can carry the light signals pass through it, and that is what said to be called as your signal is transmitting through the channel in the form of a light. Okay. So, this passing from transmitter to receiver is passing through the form of an OFC, optical fiber cable. Coming to the other hand, through the unguided, we have a transmitter and we have a receiver. See, we have a receiver. ट्रांसमीटर और रिसीवर का बीच में कनेक्शन नहीं है, उसका पास कनेक्शन कुछ नहीं है. The reason is we are talking about unguided. Unguided means we are using an antenna. So, transmitting antenna, receiving antenna, electromagnetic wave उसका बीच में सेंड करेंगे, वो गाइडेड नहीं है, अनगाइडेड है. अनगाइडेड का मीनिंग क्या है, इसका मतलब क्या है, मीन्स इट कैन बी डिस्ट्रीब्यूटेड इन ऑल द वेज and some part of that signal, what the pass of the signal will receive to the receiving side. So, this is what said to be called as the unguided we are having. So, if you talk about the unguided, there is no physical connection. The best example for that is called as the free space. Your free space simply acts as a channel. Your free space simply acts as a channel. So, it is completely about an introduction towards to the your channel, types of channel. Based on that only we have the different types of advanced communication systems are present. Okay. So, after listening the entire thing, I think students will get some idea and into the picture such that what we are studying for the next 50 hours of the subject. So, what we are studying here is, it is very simple such that this communication system is, optical communication system is guided, purely guided. It is a purely guided. That means we see about the guided connection, OFC acts as a connection. So, इसका OFC में सिग्नल सेंड करने के लिए क्या क्या मॉड्यूलेशंस, क्या क्या टेक्निक्स यूज करने के लिए, passing from one point to the another point we study in the classroom. Okay. And if you talk about the remaining things, that is, see, just you observe this part, these parts, if you observe carefully these three techniques, those are called as unguided. That is called as unguided. Unguided means wireless. Wireless means we can also call as radio communication systems. These are unguided systems we are having. okay, which are called as unguided. So, unguided systems we have. Okay, unguided system. If you talk about cellular communication, it's a hybrid model. Already I told to you, hybrid model, both are present. What is hybrid model? We are having both guided as well as unguided is present. This is called as a hybrid model is present. So, please copy this part. I can explain the part number 3. Okay, part number 3. Yeah, Vishwa Trivedi, copper means simple, regular wire only. Right. We can see about the part number 3. So, I hope copying is completed. So, we can see about the part number 3. So, once we come across the part number 3, that is part 3, and this part 3 is called data communication. It's called data communication system. If you talk about the data communication system, we will see about the introduction to the data communication system. So, what is data and how you are transferring data from one point to the another point is called data communication system. So, this nowadays is playing a very dominant role by having a more number of users of internet, more number of internet users. Data communication is playing a dominant role in transferring data from one point to the another point. Best example, you are using WhatsApp or Telegram. So, the best examples that not only those apps guys, there are so many number of apps which are passing data from one point to the another point. Easy to understand is like a Facebook is also one of the best example. So, many students will have one idea about the data. If you talk about data means, they think data means it's only text like ABCD only. No, it's alphanumeric characters. Alpha means alphabets, numeric means numbers, and the characters and comma, full stop, special type of symbols. वो भी डाटा करेंगे, डाटा का है, इसका नाम भी डाटा है. And image, your image is also called data. Video is also called data. Audio file is also a data. Voice is also a data. Anything input you convert into digital form. Digital form के change करने के बाद उसका नाम data है. Don't think only text भैया. Text is not only a data. It's a data means any form, any input form converts into a digital form as a binary form is called data. That's why I told you nowadays is playing a very dominant role in the communication system. So, data communication we are having. Introduction, we see about the different types because it takes more amount of time, more number of concepts are there in introduction. We see about the different types of connections, different types of networks, LAN, MAN, WAN, GAN, and different types of connectivities. All those things we study in the classroom. Okay, so that's why I just wrote an introduction part only, but it will takes more amount of time to explain. And second important thing that we study about here is called as OSI. Okay, open system interconnection which was proposed by the ISO, International Standards Organization. Okay, so we see about the open system interconnection which is proposed by the ISO, International Standards Organization. And the third important thing that we discuss in the classroom is nothing but about the data link layer. About data link layer. I hope students will understand that it consists of 7 layers. Out of that 7 layer, it is one of the layer. Physical layer is also there, but physical layer already you studied in the remaining parts of the subject. I will discuss that in the class. Okay. So after that, we will see about the fourth important one, that is called as TCP by IP, Transmission Control Protocol by Internet Protocol, IP. The advanced version of this, the drawbacks of this OSI and ISO rectified by the TCP by IP. The problems of TCP by IP is rectified by the Cisco model. But in the syllabus we do not have the Cisco model, we study about the TCP by IP. So next one, that is coming to the fifth one. So when you discuss about the fifth part of the data communication system, it is called as layers, which is called network layer. It is called as the network layer. And sixth part, that is called as transport layer. It is transport layer. You will study about each and every layer in detail. And seventh one, the seventh one is called as the layer, which is said to be called as application layer. It is called as application layer. And after the application layer, eighth one, we are discussing about the most important one, that is called as security. Security is nothing but an encryption and decryption bhaiya. Already you are observing that in your WhatsApp also, end to end encrypted and decrypted messages, which is one form of security. You will study about the remaining all the security, how it is perform encryption and decryption we see in this topic. Ninth one, that is applications of the data communication system, which is also an important topic that we study in our classroom about the applications like your LAN, Ethernet, and next one is about the application called as ATM, asynchronous transfer mode. Okay, not anytime money or anytime milk bhaiya. So ATM is nothing but an which is called as asynchronous transfer mode we are having. So next one is applications which we will study like ISDN, Integrated Service Digital Network, ISDN application. So all these applications we study in the classroom. So it is completely about the syllabus we are having. So this is the subject completely divided into 3 parts. If you open our workbook also, you can find the chapters in the same way. The first chapter is optical communication, second one is cellular communication, third one is satellite communication, that is the microwave part, and wave propagation combined to give as one chapter. And the remaining all the things are data communication systems in the same way, introduction, models, layers and all those things. Okay. So I will give you briefly explain about the textbooks, what the textbooks we need to prefer exclusively for the ESC. The first one is called as data communication systems. Data communication systems. Data communication systems by Forjan, B. Forjan, Behrez Forjan we are having. Okay. So B. Forjan, and second one is analog and digital communication systems. Analog and digital communication systems. Fundamentals to advance. Please refer this, don't take directly advance. Fundamentals through advance. Fundamentals through advance. The author name is Van Tomasi. Okay. So these 2 books are sufficient to cover the entire topics, and Third textbook is nothing but an optical communication system. Individual books I am giving. Optical communication systems by senior. And the fourth one is satellite communication system. It is a satellite communication system by Pratt, Timothy Pratt, the name of the author. And the fifth book, that is antennas and wave propagation. Antennas and wave propagation. If you see the antennas and wave propagation by K.D. Prasad. So these are the textbooks. So I will tell one thing, instead of referring all these textbooks, you can refer the class notes and you can refer the so-called the complete theory book, which is given for advanced communication systems. That is very much easy, because that is completely making a liquid manner present at one instant as per the syllabus. So if you study that, it will be completely covered all the topics what you study in the classroom and which are going to present in the books only present in that book. Okay. So like theory book of Medici, I am writing that also here. Theory book of advanced communication system, Medici. We just open the book, you can find out clearly, guys, what it is present in that one. So it is completely about the textbooks we are having. So next we can see about the weightage. What is the weightage of this one? That is for this subject. In ESE, by a P stands for the prelims and M stands for the mains. Simple thing that I can tell to you for the prelims is we are getting 8 to 12 questions in the prelims and 80 to 120 marks in the mains. So this is the weightage for the subject. So because why means advanced concepts, so most of the times they are so interested to ask these advanced concepts only. So that's why it is becoming more and more important. So it's a combination of totally 7 subjects we are having: optical communication system, cellular communication systems, satellite communication systems, wave propagation and antenna. After that we will see about the data communication system, that is about the data, how it is present data communication systems, and next microwave communication system and computer networks. Computer networks is also a part of this one, which is coming under the complete subject, which is a combination of totally 7 subjects we are having. So I hope everybody in the class will follow this one. So I can see in detail about when going into the concepts. So please copy this syllabus. So same, in the same manner we can study. There are so many number of topics present in data link layer and TCP, network layer, transport layer, not writing all those things. I am just giving a brief idea, so what is present in the subject. Okay, please. Right. I think copying is completed. If so, please put an message if copying is completed, like thumbs up. Right. So we can start with the part 1 for today's class, optical communication system. So, introduction to the optical communication system. So, introduction to the optical communication system. Array. So, when you see about the introduction to the optical communication system, I will explain first of all about the electromagnetic spectrum. Understand this concept carefully. Electromagnetic spectrum. So, I am drawing the electromagnetic spectrum here, showing you that all the frequencies which are present in the electromagnetic spectrum. So, you can please see here. The first frequency will start at 10 to the power of 0, 10 to the power of 1, 10 square, 10 cube. Students obviously knows that 10 cube it stands for the kilohertz. 10 cube which is called as kilohertz we are having. So, next one is it is 10 to the power of 4, it is 10 to the power of 5, it is 10 to the power of 6, 6 stands for the megahertz, it is called as megahertz, 10 to the power of 6 megahertz, right. So, next 10 to the power of 7, 10 to the power of 8, 10 to the power of 9 and 10 to the power of 10, this 10 to the power of 9 is called as gigahertz, it is called as gigahertz we are having, okay. So, after that we can see about the 10 to the power of 11, 10 to the power of 12, 10 to the power of 13, this 10 to the power of 12 is called as terahertz, it is terahertz, okay. So, 10 to the power of 12 is called terahertz, then 10 to the power of 14, 10 to the power of 15, this 15 is said to be called as your pentahertz, it is called as pentahertz, 10 to the power of 10 to the power of 16, 10 to the power of 17, 10 to the power of 18, this 18 is called as exahertz, it is called as exahertz we are having. So, 10 to the power of 19 and 10 to the power of 20 we are having. Then it is called as 10 to the power of 20 is present. Now, these are the frequencies that we are having. So, whenever we are discussing about this is called as the frequencies we have, it's called as electromagnetic spectrum, the frequencies which are present in your electromagnetic spectrum we are having. Yeah, please see here. I will explain where we are operating and what is the reason of explaining this entire thing about electromagnetic spectrum. By observe here carefully one thing, at 10 to the power of 4 we study one application which is called as your radio. That radio is called as AM radio. We study the application called as AM radio application, AM radio application at this 10 to the power of 4 hertz. See at here we study about AM radio application. 10 to the power of 6 or 10 to the power of 7 megahertz we study one application which is called as FM radio. I hope once we see about the communication system in analog and in our digital communication systems, we see about an application called as FM radio application. अगर 10 to the power of 7 मेगाहर्ट्ज के पास इसका एप्लीकेशन है, एफएम रेडियो एप्लीकेशन है. सो इसका मतलब क्या है, मैक्सिमम फ्रीक्वेंसी हम कम्युनिकेशन सिस्टम में यूज करने के लिए मेगाहर्ट्ज से तक है, अप टू मेगाहर्ट्ज ओनली. So we use up to megahertz only, 10 to the power of 6 megahertz only we use in communication system. In both, in analog and digital communication system, maximum frequency that we used is up to megahertz. And when we deal with the gigahertz, see observe here, from here onwards advanced communication starts. From here onwards. Just observe carefully, I am showing it here clearly, from 10 to the power of 9 hertz advanced communication starts. So in advanced communication, we don't use the frequencies which are having very less frequencies. So small carrier frequencies cannot be used. So हमको carrier frequency बहुत ज़्यादा frequency use करेंगे. So gigahertz, terahertz, pentahertz, like exahertz, that much high frequencies are used here. So if you see carefully about that part, that what we are having, whatever the frequencies that we used here are completely at high, at very high level we are having. And those high frequencies, when the frequency is very very high, we never calculate them in terms of your frequency. We always write them in terms of wavelength. We always write them in terms of your wavelength we are having. So just try to understand this part, all of you guys. 10 to the power of 10 hertz, which is called as microwave. It is called microwave frequency. So what you understand? Microwave and satellite communications are used at gigahertz range. Cellular communication is also used at gigahertz range. At this range we are using the microwave and cellular communication system. Now coming to the terahertz, Bhaiya observe carefully Bhaiya, terahertz 10 to the power of 12 up to 10 to the power of 16, 10 to the power of 16 or 10 to the power of 15. We are using the frequencies that is as called as optical frequencies. These are optical frequencies, light, these are called as optical frequencies. We use optical communication here, optical frequencies from 10 to the power of 12 to 10 to the power of 16 up to 10 to the power of 16, which is called as optical frequencies we are having. So we deal with gigahertz, terahertz and pentahertz. After that what happened is, this is the only light zone. See what you are finding here, this zone 10 to the power of 12 to 10 to the power of 16 is called as light zone. Is called as light zone, which is called as light zone we are having. That means optical frequencies are present here. Is called light zone. And the next important thing you observe clearly here, that is 10 to the power of 18. But yeah, just observe it. This 10 to the power of 18 is called as the X-rays. It is called as X-rays we are having. We are using X-rays here. And 10 to the power of 19 is called as the gamma rays. Is called as gamma rays we are using here, which is called as the gamma rays. Gamma rays. 10 to the power of 20 is called as the cosmic rays. This is called as cosmic rays we are having. It is cosmic rays we have. We have cosmic rays. We are not dealing with this X-rays, gamma rays and cosmic rays, but we will study up to this part from gigahertz to up to 10 power 16. We will study in the classroom. This is completely about the advanced communication signals. That means we are using in advanced communication systems. These are the frequencies we are using. And remember carefully, at high frequencies, I tell the point also to you to note in the notes, don't worry. At high frequencies, see after this gigahertz and all those things, okay, at high frequencies, we always consider wavelength. We always consider wavelength. The reason is frequency is very very high. So writing them in terms of wavelength is easy for representation. So we are taking the wavelength here. So wavelength is represented as lambda. Frequencies are represented as f. And all the students in the class know the relation between lambda and f. And that is written as like this: lambda is equal to c by f. Frequency is very very high, lambda becomes very, very less because they are inversely proportional to each other. When these two are inversely proportional to each other, your lambda is equal to C by F, frequency is very, very high, your lambda is very, very less, then what we understand clearly from this concept is at higher frequencies, you can represent in terms of wavelengths, in terms of nanometers, okay, in terms of centimeters, millimeters, nanometers, okay, like that we can write it. So, this is what said to be called as the electromagnetic spectrum. The reason for studying this electromagnetic spectrum is at what frequencies we are operating and what frequencies we are completely studying in our advanced communication system, and at higher frequencies we always deals with the wavelength instead of the frequencies. So, this is about the electromagnetic spectrum. So, students will have another doubt also here. Sir, what is the reason behind this by increasing your carrier frequency? Why you are increasing the frequency? Okay, you told that your carrier present in analog and digital communication system is only in terms of kilohertz or megahertz. Obviously, we studied a carrier signal of frequency 100 megahertz is used to carry, okay, message signal of frequency 4 kilohertz. Like this we study in the systems, in communication systems. Same thing bhaiya, here also your carrier must be very high frequency. So, बहुत ज़्यादा frequency है भैया, ज़्यादा frequency है, that is gigahertz, terahertz, pentahertz. So, वो इसका पास करने के लिए सिग्नल, कैरियर सिग्नल का frequency बहुत ज़्यादा हो जाएंगे. I can explain one concept. Already you study in the communication systems because some students are not completed the communication system. That's why I'm explaining that part to you once again here, which is called as your bandwidth utilization ratio, which is called BUR, bandwidth utilization ratio. If you talk about the bandwidth utilization ratio, that is called 10% of your carrier frequency. That means how much amount of bandwidth that a channel can offer, and that bandwidth how much you utilized can be calculated. See, here very important thing is how much capability is having for the channel to provide a bandwidth. So, that is called channel bandwidth भैया दो तरह बैंडविथ है, एक है सिग्नल बैंडविथ है, दूसरा वाला है ना चैनल बैंडविथ है. सिग्नल बैंडविथ के लिए कैलकुलेट करने के लिए बहुत इजी है, बहुत फॉर्मूला भी है कम्युनिकेशन में, बट चैनल बैंडविथ कैलकुलेट करने के लिए ए चैनल बैंडविथ इज कैलकुलेटिंग एज टेकिंग एज ए कैपेसिटी फॉर्मूला C इज इक्वल टू B into log of 1 plus S by N of base 2, which is called as your Shannon-Hartley law. Right. So, putting those things in the other side, I will tell one thing. Another important formula is also there. What we study in the communication is called as BUR. BUR stands for the bandwidth utilization ratio. I hope students will understand clearly such that I am discussing this point only for regarding to explain one simple thing. What is the necessity of increasing the higher carrier frequency? So, what is the use of taking the higher carrier frequency? Why you are not confined to kilo and mega, but why you have confined to giga, tera, penta also? Okay, exa, please leave about that exa. See, what is T stands for, bhaiya? G stands for giga, T stands for tera, very good. P stands for penta, yes or no? Pentahertz. Okay. E stands for exa, it's called exahertz, EXA, exahertz, right. So, obviously study about 10 power minus 3 milli, 10 power minus 6 micro, 10 power minus 9, come on tell, nano, very good, 10 power minus 12 pico, 10 power minus 15 femto, 10 power minus 18 alto, small car now, chota car, board, chota car hai, a small car which is called alto. Right, that is a name they give like that. So, I hope you understand that. See, I think I will write those things also here for your reference purpose, bhaiya. So, 10 to the power of minus 12. So, 10 to the power of minus 12 is one thing. 10 to the power of minus 9, which is called as nano. 10 to the power of minus 9 is called as nano. 10 to the power of minus 12, I think I need to write the remaining all things. I can write for the remaining one, which is called as the 10 to the power of minus 12 is called as, is it required to write 10 power minus 9 also? So, dekho bhaiya, 10 power minus 9, 10 power minus 9 is called as which one? Nano. 10 power minus 12 is picofarads, like pico we can study in the class also. 10 to the power of minus 15, which is called as femto. It is called femto. So 10 to the power of minus 18, so minus 18, which is called as alto. It is called as alto. So it is completely about the different types of the measurement values we are having for writing the milli values. Okay. So please copy this. I will tell one point and I explain the BUR to you, bandwidth utilization ratio. Okay. Please copy it, Nana, all of you. Yeah, Soumya, thank you for putting a message. Write down, guys, one point you can write it as a note. First point here. First point you can write. Point number 1. When dealing with ultra high frequencies, it is common to use units of wavelength rather than frequency. First point. It is common to use units of wavelength rather than frequency. Okay. So rather than frequencies. Right. Next one. Rather than frequencies. Next one. Please put the heading as bandwidth utilization ratio, BUR. Bandwidth utilization ratio. Bandwidth utilization ratio. BUR, bandwidth utilization ratio. Next topic is BUR, bandwidth utilization ratio, which is called as bandwidth utilization ratio. So we can give like this: BUR is equal to 10% of carrier frequency. It is called 10% of your carrier frequency. So how much amount of bandwidth that offered by a channel? See, for example, if you take a copper channel, the maximum frequency that can be withstand by a copper cable is kilohertz. If you take coaxial cable, megahertz. If you take waveguide, gigahertz. If you talk about the same thing as optical fiber cable, they can all sustain up to terahertz, because optical signal starts at terahertz. You see in the electromagnetic spectrum, starts as 10 power 12 to 10 to the power of 16. That's a frequency, optical signal. So you observe clearly such that BUR is equal 10% of carrier frequency we are having. It's a 10% of carrier frequency. So what it is having is like this, which is called BUR. BUR is equal to 10% of FC. But yeah, FC becoming very, very high, the utilization ratio become very, very high, amount of bandwidth offered by the channel is very, very high. The more bandwidth the channel can be sustained, the channel can be provided, then obviously what happen means we can going to be send more number of signals pass through it, which is called BUR, bandwidth utilization ratio. Now see, I can give a small example to you to understand clearly such that FC is taking equal to value is equal to 10 kilohertz. To make the calculation easier, I am taking my carrier frequency FC is equal to 10 kilohertz. Then what you understand is BUR, bandwidth utilization ratio, is equal to 10 into 10 kilohertz, because FC is 10 kilohertz. I substitute this here, whole divided by 100, and this will get cancelled out to each other. Then your bandwidth utilization ratio is equal to 1 kilohertz. What's the meaning of this one? If your carrier frequency is equal to 10 kilohertz, then definitely the amount of bandwidth offered by that particular channel is 1 kilohertz. That is equal to 1 kilohertz we are having. I hope students understand this one. That's the main reason bhaiya, copper cables are providing very less amount of bandwidth, and we are going to be sending a less number of signals. On the other hand, if I take my carrier frequency FC is equal to 10 terahertz, to make our calculation easier, I will talk about the BUR, bandwidth utilization ratio, is equal to 1 terahertz. This calculation is not required anymore. Why? Because means 10 kilohertz will give 1 kilohertz, samely 10 terahertz will give 1 terahertz. See, 1 terahertz of bandwidth means huge amount of bandwidth is provided by the optical fiber cable. That's one of the beautiful advantages of optical fiber cable systems. They provide a huge amount of bandwidth bhaiya. We can send more number of signals, high amount of data rates will be carried. So fast amount of data rates, very fast it can be carried. So approximately very close to the light of speed. So light of speed, light or speed light or light of the speed it is carried. So this is called as the one of the beautiful advantages we are having. Not only speed, on the other hand it is giving more amount of bandwidth, high data rates will be carried off, and that is more required. That's the reason when you are using an optical fiber cable for internet, you are getting 1 Gbps, 1 gigabits per second data rate we are getting. That means you are enjoying the streaming like our channels continuously without having any buffer, like 24/7 you are going to be seeing your favorite channels or favorite movies at any cost. Okay, so the reason is speed matters bhaiya here. Speed matters, which is having very high speed is present, and this is completely an advantage we are having for moving to the high frequencies. So why you are increasing the frequency in communication systems, advanced communication systems, means to get the amount of bandwidth offered by the channel is very, very high. That is BUR, bandwidth utilization ratio. Now I already told to you such that in the class that we are having a light region. That light region is divided into 3 parts. Please concentrate. Light regions are divided into 3 parts. So, thoda attention pay karo here. There are 3 light regions we are having. So, the 3 light regions we are having. So, pehla wala, number 1, infrared bhaiya, which is called as infrared light region, which is called IR region also. Simply we call it as IR, infrared region, IR region. So second one is called visible light. Visible light is the light which is visible to the human eyes. Your human eyes can going to be visualize some colors. Yes or no? Like a red color or black color, white color, blue color. Yes or no? So that's what the visible light. So some visible light we are having. Human eyes will respond to this light, which is also called visible region. Third one is UV, ultraviolet, which is called UV region. It is called as the ultraviolet region we are having. It is called ultraviolet region. So this is completely about the 3 regions we are having, light regions. So the 3 regions are nothing but an IR, infrared region, visible light, and ultraviolet region, UV region. I hope it's clear. Everybody in the class, I think there are no doubts regarding this. Okay. So, hope it's clear to everybody in the class up to here. Right. Bhaiya, I will start explaining you about the IR. So, what is IR? So, IR frequencies are going to be starts at 10 to the power of 12. And I don't want to talk about the frequencies Bhaiya here. I need to always discuss about the wavelengths, that is present from 770 nanometers to 10 to the power of 6 nanometers we are having. Okay, that is 10 to the power of 6 nanometers we have. So, wavelength ranging, that is the wavelength we are having. Already explained why we are discussing about the wavelength. At higher frequencies, we always deal with the wavelengths instead of frequencies. That is why we are talking about the wavelength. I hope you understand the interlink that why I explained about the electromagnetic spectrum to you in the introduction. So, and that is linking here. So, what is the capacity of the channel? The capacity of the channel is given by the Shannon-Hartley-Law, because that depends upon the signal to noise ratio also once again. But BUR is also a very important parameter which decides the amount of bandwidth utilized for a particular channel. So, copper cable can carry only maximum up to kilohertz. That means the amount of bandwidth offered is also in terms of kilohertz. Coaxial cable megahertz, already told to you. So, bandwidth utilization ratio is in terms of megahertz only. But if you come to the other hand, your waveguides, or if you talk about your optical fiber cable, they are giving you the more amount of bandwidth. They are offering higher bandwidths by higher speeds, higher data rates will be carried, more very high data rates will be carried. But the problem here is in gigahertz, we have a electric signal will be passed, but the designing parameter is very difficult, waveguides. I will discuss that point when it comes in the microwave communication system. I definitely explain you that why the waveguides are not that much responsible to, are not used for very long distances, why are using only for short distance, I explain to you. Now, you come to the other hand, that is a waveguide, but terahertz, if you send the signal, the terahertz starts with the light signals, that is why it is called as optical communication. Your carrier right now acts as which one? Optical. Carrier is optical signal. Electrical signal instead of electrical signal के पास इसके बदल हम optical signal send करेंगे. Optical signals carry the signals from one point to the another point. इसके लिए communication बोलिए, optical communication है. This is the basic thing that everyone will knows. Second note for the student, why you using optical cable? Why you are using optical signals and why the higher frequency is used? Because of BUR. In that light region, starts at 10 to the power of 12 to 10 to the power of 16 hertz. I am writing that region also, light region Bhaiya. No doubt, please just observe this part, already we discussed in the classroom. 10 to the power of 12 to 10 to the power of 16 hertz. 16 hertz is nothing but in our light region. In that we have three regions, one is infrared, second one is visible light, and third one is ultraviolet region. Hope it's clear? Clear na? Right. So, if you have any doubt, you can put in the chat message box. I can explain to you about that. Okay. So, please see here IR region. I am explaining you about the IR region. Bhaiya, थोड़ा attention pay करो. ये topic बहुत important है. So, which region है and responsible regions and types of that IRs we can have. Okay. IR. If you talk about this IR, it is the wavelength, and I need to explain you about what are the different types of IRs we are having. The first IR is called as the infrared region IR, which is called as the near IR. It is called near IR, near infrared region, near IR. Second one is called as the near IR, means that is very close to 10 to the power of 12 hertz. See, देखो भैया, इधर 10 to the power of 12 hertz लिखे ना, इसके लिए very close to this frequency is very close to 1 terahertz or 0.5 terahertz, like 1.5 terahertz. Those frequencies are called as near regions, near IR. वो near IR है. So देखो इधर वो near IR है. और next के लिए near IR के बगल हम दूसरा वाला है, इसके लिए कॉल एज मिड IR है, मिड इंफ्रारेड रीजन. It is called mid infrared region. So next one what we are having is called as a far infrared region Bhaiya. Far infrared region means it is very close to the visible light. Hope it's clear now. Very close to the visible light. Okay. And last one classification we are having, bhaiya, a far infrared, bhaiya, far hai. Very far away from 10 to the power of 12 hertz. Okay, which is called as far infrared we are having. So this is completely about the IR. So IR, next important point, most of the optical communication systems, OC stands for optical communication systems, works at IR. So I hope everybody can understand here. Right, understand me? So most optical communication systems works at IR, works at infrared region, at IR region है. Clear है भैया? Right. Now देखो भैया, दूसरा वाला है ना visible light. Students, please concentrate on the topic what I am discussing. Don't worry, points I will explain to you later on to you as a note. Don't worry about that. You just listen what it is present. Visible light, simple thing I will tell to you is visible light is the light to which human eyes will respond. Human eyes will respond to some light, yes or no? Yes, you are seeing different colors with the beautiful eyes, nature, enjoying like anything bhaiya. So many number of colors we see all the day. Okay, and those colors what you are seeing are given by the God gift that the light is reflecting and which you are seeing by our eyes, which are called visible light. Okay, so visible light के लिए हमको rainbow colors है, बहुत LKG से भी पढ़ेंगे rainbow colors. So to understand this rainbow colors, what we studied, we are having 7 rainbow colors. So Wijber, I hope you got this one. So Wijber. Okay. Now V stands for, V stands for violet. Very good. All are revising now. Come on, start. Violet. Still. Next. I stands for indigo. Super nana. B stands for blue color. G stands for green है, Y stands for yellow, भैया बोलो भैया, O stands for orange, R stands for क्या है, red color. Okay, R stands for red color. Just observe carefully, we are having that 7 colors which is called violet, indigo, blue, green, yellow, orange, red. I want to tell you one point here, just try to observe it. This violet, indigo, blue comes under blue family. Blue family bhaiya, thick blue, pale blue, that blue, this blue, all blues only come from the combination of these colors only. That is violet, indigo and blue, which comes from the blue color. Okay, next bhaiya, green and yellow. These two are called as green family. I will explain a simple example to understand that. I think you observe the nature very well. Nature will make us to learn so many number of things. In that part, we can see one thing, that is trees, which are green in color. When you are mood out, you can just say one tree, like this your mood will automatically change. So when you are angry, your face is so red color, if you just see that green color tree, your angriness will decrease. Yes or no? Right. So just simply see that it is having a green and a yellow. Photosynthesis is greater than 60%. Of course, how much it is? Greater than 60%. The color is such as in a green color, thick green color. When the photosynthesis is in between 30 to, like 60%, in between 30 to 60%, you can find out that the amount of thick green color will decrease and become as a light green color. Okay, like peacock green also, like peacock green, we can call it as light green color. And if the photosynthesis is less than 10 to or in between 10 to 30%, the color of the leaf was going to present as yellow color. And if it is very less than that, it will fall down from the tree and converts into brown color bhaiya. I hope you observe these parts of a leaf, right? So these things are nothing but, and we can understand clearly such that one important part, this yellow color is also coming from the trees only, from the green color only. This is the part of green, like light green, pale green, yellow, brown. All this comes from this green family only. In the other hand, if you observe this orange and red, which is called as the red color we are having. It's a red color. Like red family means orange, red, like pink, baby pink, light pink. Girls will know about much about these colors, bhaiya. They like very much pink all the time, right? So these colors, which is going to be the red color, is the family of all those colors we are having. So what's my main point I want to tell to you is the combination of this entire universe was having with the colors of RGB. That is called as RGB. I want to write this one RGB by red, green and blue. If you talk about the connections of your electrical connections, 3-phase connections, light connections are also having the same colors. RGB we are having red, green and blue. So that is the concept. So trillions, millions of colors you are going to be generating with the combination of only 3 colors, that is R, G and B only. And those combinations only give different types of colors will be happening. I hope everybody in the class understood that. This is the visible light. Visible light is the light which is having, okay, which is responded by the human eye, having these many number of colors. And I need to talk about the wavelength also. So please give me some amount of time to explain you about the wavelength. So starts at 390 nanometers to 770 nanometers. By in some books they write 400 nanometers to 800 nanometers. Of course, it's a light having some spectrum. So change in the spectrum we are having. The calculations will also be changed from book to book. They can write different colors, but it starts from 390 to up to 800 megahertz we are having. Okay, so up to 800 nanometers we are having. So it's the wavelengths. It's the wavelength we are having, which is called visible light is present. So I hope everybody in the class understood this. So next one is called as UV light by ultraviolet light or UV region. Ultraviolet light or ultraviolet region we are having. So what it may be, it is both are same. Ultraviolet light or ultraviolet region we have. So I can discuss about the UV region. So this is UV region we are having. Once you talk about the UV region, ultraviolet region, it's also have 3 parts bhaiya. So we can tell like this, it starts at 10 nanometers to 390 nanometers we are having. So starts from 10 nanometers to 390 nanometers. It is very far away, very high light region we are having, which is not possible to see with the human eyes. Ultraviolet rays coming from the sun, which is not possible to see by ourselves. Because the wavelength is very small, we are not able to see that much wavelengths. Because up to the visible light we can see, we can't see with the ultraviolet rays. Okay, so if you talk about this UV region, in the UV region we are having 3 regions bhaiya. One is called as the near UV, which is called as near UV. Other one is called as the far UV. Far UV means far ultraviolet rays. Other one is called extreme UV, which is called as extreme UV. Okay, so the UV rays coming from the sun was safeguarding us from that UV rays with those interaction for a human body with the UV rays with the ozone layer, obviously known as O3, ozone layer. That ozone layer is making us to definitely helping the mankind to reduce the effect of that UV rays. The amount of UV rays coming to the earth is very less because of that ozone layer, right? So this is completely about the UV region. So 3 regions we are having. So one point please remember carefully out of all these things, that is our optical communication system is working in IR region. IR region stands for infrared region. Definitely I will explain to you when time comes why you are using only at the IR. Please remember this point. I will make it clear in the classroom with the derivation to you. Why you are only using the IR region optical communication system? Why not visible light and why not ultraviolet rays, even though you have a huge bandwidth also? Why? Because it is 10 power 12 only, but this is 10 power 16 by 10 power 16 means you will definitely give 10 power 16 hertz of bandwidth. Huge bandwidth is given, but we are not using at this region. We are only focusing on the IR region, because at this instant I am not able to explain that to you. But when time comes, when you go into the concepts, I definitely explain with a good derivation to you how it is affecting the IR. By using IR, how you are decreasing it. Okay, so why only IR is more suitable in optical communication systems. Okay, I hope everybody in the class understood this point. If it is clear, please put a message clear or thumbs up in the chat box, and I can go for the other topic. And if you have any doubts, please ask bhaiya. Don't feel hesitate to ask in the classroom. Please ask in the classroom itself, clear itself. Okay, and the next important point is if you complete copying this, I can tell you the points regarding these 3 as a note to you. Okay, please copy it, Nana. Don't forget to put a message. If it is complete copying, because time is most valuable भैया, we don't want to waste our valuable time. टाइम वेस्ट करने के लिए मेरा को मन नहीं है. देखो ना, प्लीज आफ्टर कंप्लीशन ऑफ दैट इमीडिएटली पुट अ मैसेज. आई विल टेल द पॉइंट्स. वी स्टार्ट विद द नेक्स्ट टॉपिक. ओके. You can copy from this part, BUR onwards. Yeah, Anju Naik, what the question you asked is, such low wavelengths of gigahertz, terahertz signals, will any booster used for making it travel long distances? Means definitely we use a booster. The booster is also called as a repeater. I discussed the topic to you in the next coming class, today's class only. I can explain that to you. Okay. Yeah, thank you Keshav. Thank you Nayak. Thank you. So please write down the point. I think many students has put the clear message. Copying is also completed. Oh, thank you. Thank you for putting the message. Keshav. So I can just scroll it up. You can please copy this part also, Bhaiya. All of you please copy this part also. Up to this part. You please remember these values of wavelengths. IR region is 770 nanometers to 10 to the power of 6 nanometers. Visible light is from 390 nanometers to 770 nanometers, and your ultraviolet region is 10 nanometers to 390 nanometers. In the ESC question, if you find out it's from 400 to 800 nanometers, it's correct. Visible light from 4 nanometers to 790 or 800 nanometers is also correct. Please copy it, Nana. Write on the note first point. Students, write on the note first point. Please put the heading as IR, infrared region. IR, infrared region. Write on the first point. Put the heading as IR. IR stands for the infrared region. IR stands for the infrared region. Okay, right. First point. The band of light frequencies, the band of light frequencies, the band of light frequencies that is too high, the band of light frequencies that is too high, that is too high, TOO, too high to be seen by the, too high to be seen by the human eye, too high to be seen by the human eye, with wavelength ranging from, 770 nanometers to 770 nanometers to 10 to the power of 6 nanometers. 10 to the power of 6 nanometers. Okay, first point, that is 10 to the power of 6 nanometers. 10 to the power of 6 nanometers. Right. Second point. Point number 2. Optical fiber systems generally operate. Optical fiber systems generally operate in the infrared region. Generally operate in the infrared region. Operate in the infrared region. Okay, in the infrared region. Right. Next one. Please put the heading as visible light. Visible light. Put the heading as visible light. First point, the band of light frequencies, to which the human eyes will respond, with wavelength ranging between 390 nanometers to 770 nanometers. 390 nanometers to 770 nanometers. Okay, to 770 nanometers. Next point. This band will be visible to the human eyes. This band will be visible to the human eyes. Right. Please put the heading as next one, ultraviolet region, UV region, ultraviolet region, UV region. Okay. Yes. Write down. First point, the band of light frequencies, that are too small, TOO, too small to be seen by the human eye, with wavelength ranging between 10 nanometers, 10 nanometers to 390 nanometers. 10 nanometers to 390 nanometers. 390 nanometers. Okay, right. So this is completely about the electromagnetic spectrum. Okay, so why light frequencies and why all these things we studied right now. Okay, I hope you got to clarity. So where we are operating, one important question that asked in the exam in ESC is where the optical communication system is operating. That is operating at which one? At IR. Good Bhaiya, good answer. And second important thing is, Bhaiya, please remember these wavelengths. These are very, very important. The wavelengths we are having are very, very important. Please mark them in your notes by highlighting that, by using a highlighter or by using a red color pen also. Please highlight it. Right? These two are very, very important questions that ask in the ESC exam. Clear hai na? Next topic we are starting, Bhaiya. So please attention karo. Pay the attention, all of you. I hope copying is completed. Thank you for responding and putting a message. See, the interaction between you and me is only through the chat only. Anything you have a doubt, anything I need to ask you, or you need to ask anything, please put in the chat. Okay. So if it is clear copying, please clear sir. This is clear sir, or copying complete sir, whatever it may be. In a short form also, like simple thumbs up also, instead of typing all the time. Right. That I can make and clear such that you complete copying and I can explain the points and I can start the next topic. Okay, right. Bhaiya, see here. First class na, so some synchronization has to be required. More synchronization, more information will transfer between you and me. Okay, right. Come on, Bhaiya. Next topic I am telling is simple block diagram of optical communication system. Okay, so simple block diagram of optical communication system. Bhaiya, OC stands for optical communication system. Okay, FOC means fiber optical cable. What is OC? OC is called as optical communication system. ये ऑप्टिकल कम्युनिकेशन सिस्टम है भैया, शॉर्टकट है, ठीक है ना, राइट. OFC स्टैंड्स फॉर व्हिच वन? ऑप्टिकल फाइबर केबल. Okay, so this is the shortcuts we are using in the classroom. Okay, right. See, simple block diagram of optical communication system. Before going to explaining you this, I will tell you one thing. In any communication system, we are having 3 blocks. Already explained to you. First one transmitter, second one channel or medium, third one is receiver. Optical communication system also consists of 3 blocks: transmitter, channel and receiver. But the only difference is the channel is not an electrical channel, it's not a copper wire coaxial cable, it's not in a form of electrical signals, it carry optical signals. Okay, now see the difference. Bhaiya, first thing is I want to tell you about the carrier frequency. If you talk about the carrier frequency is present from where to where? 10 to the power of 12 to 10 to the power of 16 hertz we are having. Okay, so this carrier frequency in nature is which nature? It is optical in nature. So optical in nature means now your carrier signal is optical, which carries your message signal from one point to another point. Okay, if your message signal is analog, it is called analog optical communication system. If your message signal is in the form of a digital, you know how to convert an analog signal into digital signal, because we studied that we have 3 steps. Bhaiya. First one is sampling, second one is quantizing, third one is encoding. If you convert by using these 3 steps of analog signal into digital signal, and that digital signal is transmitting by using your light signal carry these ones and zeros, it's called as digital optical communication system. Okay, it's called digital optical systems, we are calling it as. I hope everybody in the class understood this point. So what we are talking about this is your carrier frequency is this, the nature of the carrier is optical in nature. So we are replacing electrical carrier signal with optical carrier signal. That's the main point you must observe when we are discussing about the your optical communication system. So next one is I want to explain you about the most important thing, that is called as the wavelength. Okay, so we can call it as wavelength, what is called as operating wavelength. Dear students, already I told to you why we are discussing about the wavelength, because at higher frequencies we are operating, our systems are not explained with respect to the frequency, we are always discuss them with respect to the wavelength. So wavelength is more important. So wavelength, operating wavelength of your optical communication system starts at 800 nanometers to 1600 nanometers. In between this only we will operate. Why we are operating in between this means? That's very clear, Bhaiya. We are using IR region, and for that IR region we are designed in this region. So there are some other parameters are also. When I goes into the concepts, I can explain that to you. In attenuation, I give a clarity regarding this. Okay, because today's class, very introduction, Bhaiya. At the introduction stage, we are having learning the things, what the difference is, and what we study communication, and how all those things we are seeing here. Okay, so I hope everybody in the class will understand this part. So hope you understand this one. Your optical signal is in nature, and now your transmission line, that is called channel. Bhaiya, the channel we are using here is called as optical fiber. Okay, optical fiber cable, which is called as OFC. We are using the OFC, optical fiber cable is using here as a channel. Now see the block diagram. Just please focus on the block diagram. Already told to you we have 3 blocks. The first block is called as transmitter, and the transmitter is connected through the channel, and that channel is showing like this. What's the meaning of this one means? It's a very long distance. Okay, long haul communications. What's called as long haul communication or long haul communication. The meaning is nothing but it is used for very long distances, like thousands and thousands of kilometers of distance. We use the cable, and that is represent like this bhaiya. So like showing like this means arrow around means used for very long distance. The cable can be used. Communication is possible for very long distance also. Okay. Now see here at the other end we are having which one? Receiver. So please bhaiya concentrate karo. Receiver. Sorry for this, have a receiver, and that is shown with the diagram. We have a receiver here. So if you talk about the receiver, the receiving block diagram is present. So this is completely the setup we are having. So what is this? This is called as channel, and that runs for a length called as L. L stands for the length of the fiber OFC. Length of optical fiber cable. L is length of OFC optical fiber cable, and this optical fiber cable is having a nature called as dielectric in nature. It is dielectric in nature. The nature of that optical fiber cable is dielectric in nature. Now second important point you need to consider here is this optical fiber cable will carry only which signals? Optical signals. देखो भैया optical signal is carried. देखो what receiver also receives which signal? Optical signal. I hope everybody in the class understood these 2 points. First one is optical. Okay. Optical signal, right? So it's called as optical, and that is the OFC fiber cable will carry that optical signal. I hope everybody in the class understood this. This is the fiber. I am telling 2 points. This fiber is OFC cable, optical fiber cable is having dielectric in nature. First important point. Second point is it can carry optical signals through it. Optical signals will be passed through this from very long distance. Such type of communication is called as long haul communication. So this round indicating the long distance we are using. L is length of the OFC, length of OFC optical fiber cable. If you feel difficulty of optical means we can tell light also. Light and optical both are same bhaiya. Okay, light region, optical region, light source, optical source. Okay, light detectors, photo detectors we call it as. Okay, the name itself is different but concept remains the same. Here the light is acting as a carrier. Okay, so I hope everybody in the class understood this. Bhaiya, we know that for every transmitter, the input what you are giving is nothing but an message signal, right? The output of the receiver is also a signal that is called as the message signal. That's what communication is doing. So what I am transmitting, okay, through a channel received by a receiver, I'll give that one. Assume that 2 friends are speaking in a telephone system. If you say hello, your friend was expecting the same hello on the other end. Okay, if you say hello, it gives bolo means it will be different bhaiya. It may not be get the same thing. It doesn't give a good impression also. What you are delivering, you are expecting the same to be delivered to the other end. Okay, and that's what said to be called as the input you are giving as a message signal here. हम message signal का input transmitter के देने के लिए output of the receiver भी expecting the message signal है. Message signal expecting है output के लिए. Same signal है. Now see, all the input signal what you are having is having a nature called as electrical nature. They are electrical signals. They are electrical signals. Why? I can explain very clearly a simple example to understand this without wasting any time. Very simple is, भैया हमारा voice के लिए vocoder को voice generate किया, vocal cord से voice generate हो गया, right ना? And such voice signal है ना, ये voice signal हमारा माइक्रोफोन के पास आ गया. ये क्या है? नॉन इलेक्ट्रिकल है. ये नॉन इलेक्ट्रिकल सिग्नल ये माइक्रोफोन क्या करेंगे? ये माइक्रोफोन इलेक्ट्रिकल का चेंज करेंगे. चेंज करने के बाद क्या हो जाएंगे? इसी कॉपर वायर से इलेक्ट्रिकल सिग्नल हमारा ट्रांसमीटर का पास आ गया. देखो भैया ये हमारा ट्रांसमीटर है. ये क्या ट्रांसमीटर? वायरलेस ट्रांसमीटर है. देखो ना, ये वायरलेस ट्रांसमीटर है. ये वायरलेस ट्रांसमीटर में ये क्या है? एंटीना है. ये एंटीना सिग्नल को पास करने के लिए हम रिसीवर को रिसीव हो जाएंगे और तुम्हारा पास का डाटा केबल से पास हो गया और इंटरनेट के पास तुमको आ गया. इसका प्रोसेस के लिए कितना टाइम आएंगे? टाइम चले ना, इधर से उधर जाने के लिए वो टाइम क्या है, लैग का बोलेंगे। इसके लिए लैग कम होने के लिए बहुत अच्छा इंटरनेट चाहिए, स्पीड ज्यादा चाहिए, फास्ट ट्रांसफर करने का जरूरत है। इसी के लिए क्या करेंगे, हम ऑप्टिकल फाइबर केबल यूज करेंगे, राइट। ऑप्टिकल फाइबर केबल क्या करेंगे, सिग्नल को बहुत फास्ट चलेंगे और लैग कम हो जाएंगे। इसी लैग में हम प्रोपगेशन टाइम से बोलेंगे। A propagation time taken by a signal to propagate from transmitter to the receiver. This is the process, bhaiya. Hope you got it, na? A simple example will make a clarity to you. Now, what the signal you are giving, bhaiya? This signal is giving is an non-electrical, but that converts into electrical, and that electrical signal right now converts into optical, and that optical is passing into a channel, fiber optical cable, very fast, bhaiya. Fiber optical cable, light signal travels very fastly. Therefore, you are getting very small amount of propagation delay. Clear, na? So that's the reason we want high speed internets to carry high speed data, okay, to carry very fastly, and also having more amount of bandwidth. You can multiplex more signals, and this is the complete phenomena that we are having when we see about any communication system, right. So in optical communication system also, the input you are giving is electrical signal. So what you are expecting at the output side, you are not getting some digital like 1010 and not adding it. You are also getting as output as a voice signal only. What I am speaking here, you are listening on the other end, okay, at different locations. See, not at one location, bhaiya. One is at Delhi, one is in other at Hyderabad, and one is at Pune, and one is in another place like Bihar or like in Uttar Pradesh. Okay, like different places, because I can't explain all the states right now in India, like all the states of India, or maybe in different countries also. In Pakistan also they are learning the class, bhaiya. Okay, who knows? You are preparing for Pakistan PPSC, Pakistan Public Service Commission, right? So very interesting thing is such that it is going to be transmitting from one point to the another point, long distance communication. So it is electrical signal we are having. So output what you are expecting is also an electrical signal. Okay, is also an electrical signal we are having. So it is completely what you understand clearly up to right now is the input what I am giving to the transmitter, one point, input what I am giving to the transmitter, the output what I am getting at the receiver must be same. Okay, must be same. But there are some constraints that may not make it same, may not be a replica, okay, may not be make it same, but we are making it close to the same. So close to the same. That's why noise cannot be removed, bhaiya. Noise can be reduced. Removing and reducing are completely different constraints. That completely different. If you remove the noise, if anybody tell if you remove the noise in the sense means, you can tell very simply, it's not possible to remove the noise, sir. We can reduce the effect of noise. Okay. So students, I hope it's clear for you. I can explain you some of the points. Please concentrate here. I hope everything is clear up to here. This is about the simple block diagram. We have 3 blocks. I hope you complete writing also. Yeah. Start with the next one, bhaiya. Transmitter I am explaining. Dekho bhaiya, transmitter I am explaining. All of you please see here. I am focusing on my transmitter explanation. Okay, next I explain about the cable. Next I explain about the which one? Receiving section. Right. Color change bhaiya. Green color use करेंगे transmitter के लिए. बोलो भैया. First one is देखो. Your transmitter is converting from electrical to optical, which is called as E by O conversion. The reason why it is required, the first task or the first important thing that performed or the first duty of your transmitter is to convert electrical to optical. That's called as E by O conversion is required. If you talk about the E by O conversion is required, okay. E by O conversion is required, electrical to optical conversion. The reason is, why you are using this conversion is, it's very simple, bhaiya. Your cable can carry only optical signals, but input is in the form of an electrical. To make your signal to carry into a channel, we need a conversion. Such conversion is called as E by O conversion. Okay. So coming to the second point. This E by O conversion is done with the help of light sources. the help of light sources. Your light sources will perform this operation, which is said to be called as your light sources will convert electrical to optical. The first type of light source we are having is LED, light emitting diode. Light emitting diode. The second one is called as laser. Laser stands for light amplification stimulated emission of radiation. It is called as laser. So this is what the conversion done with the help of a light sources. The third important task performed by the transmitter is modulation. So any transmitter will perform which one, bhaiya? Modulation. So what is meaning of modulation? Modulation means changeover, changing is called modulation. Converting your low frequency into high frequency is called frequency modulation. Okay, changing your uniform velocity into non-uniform velocity is called as velocity modulation. Changing your current is called as current modulation. Changing voltage is called voltage modulation. Any changeover is called as modulation. Quite simple, bhaiya. No big definitions we are having. It's very simple, changeover. So changing your low frequency to high frequency is called as modulation, which we use in communication systems, also called as frequency modulation. In simple words, we call it as frequency translation. Okay, and we can tell about these things, which is called modulation, bhaiya. When we talk about the modulation, we are discussing about the only one type of modulation that must be used in the entire optical communication is intensity modulation. That is called as intensity modulation. So what is the meaning of intensity modulation? The name itself indicates intensity. Intensity means the light intensity, lumens will be changed. Unit of intensity lumens, the lumen will be going to be changes. Okay, what is changing? The intensity of light is changed. Change is also called as modulation. Now see here, bhaiya, I have a light source which is giving input bit as 1. For input bit 1, it is on. On means it has to produce some intensity, some amount of intensity will be given by the light source. For bit 0, it is off. Like making your light to be on and off, on and off, on and off, your intensity will changing, na? And like that the pulses will also be changing the pulses and transmitted. Now see here, for on you can send one pulse, light pulse, and for 0 we cannot send any light pulse pass through it, which is said to be called as your intensity modulation. The modulation that we use in the entire optical communication system is intensity modulation. We don't have different modulation techniques, bhaiya. But we can also use your ASK, PSK, FSK concepts here also for transmitting your signal in digital communication system, that we can use here itself also. Okay, but modulation technique that used is which one? Intensity modulation only, right? So the reason is, I can just explain very simple thing to you. We have a raw data 1 and 0, and that we are converting that 1 and 0 into electrical signal. Electrical signal can be used any digital modulation technique as ASK, amplitude shift keying, FSK, frequency shift keying, PSK, phase shift keying. I hope everybody can understood this. Clear na? Now bhaiya, coming to the next important point about the light source, we can discuss it here. Two types of light source, LED and laser. What's the light source is doing? Light source is converting current into optical signal. Your light source is converting your current into optical signal. I hope everybody in the class understood this. Now coming to the optical fiber cable, bhaiya. Optical fiber cable is having dielectric in nature. Just observe this. They are dielectric in nature. Already written here. They are dielectric. The nature of the optical fiber cable is dielectric. Second one, materials used. The different types of materials that are used for your fiber is, first material is called as glass. Glass is used for manufacturing of your optical fiber cable, and we are also use plastic. Plastic is also used for the manufacturing of the optical fiber cable. That is completely about your optical fiber cable. Next one is, we will see about the next one, that is called as receiving section. But your receiver always performs the reverse operation to the transmitter. Remember this carefully. Whatever the transmitter is doing, your receiver can perform the reverse operation. And students obviously knows that. We study about the invertible systems. called as inverse systems in signals and system. I hope you understand that. The best example of such inverse system or invertible system is communication system. Yes or no? The communication system is the best example of your invertible or inverse system we are having. Why? Whatever the operation the transmitter performs, completely reverse will be performed. What input you are giving and what output produced by the receiver must be the same. So, what is the inverse system? The same thing, bhaiya. In inverse system, what are the input x of t you are giving? After doing the inverse, you can expecting the output as x of t only. That's called inverse invertibility. Hope you clear, bhaiya. Right. If you see here, the task performed by the receiver is completely opposite of your transmitter. See, E by O conversion. Can you please tell me what the opposite of that one? Come on, what is that? O by E conversion. Very good, bhaiya. So, see here, that is called O by E conversion. So, what the inverse of E by O conversion is? O by E conversion. And now see here, E by O conversion is performed by light sources. So, O by E conversion is performed by using the light detectors. Source का opposite है, detector है. So, we can call it as light detectors. Light detectors are also called as photodetectors, bhaiya. These are also called as photodetectors we are having. So, these light detectors or photodetectors are of three types. The first one is called as PN photodiode. See, PD stands for photodiode. Okay, photodetector, sorry, photodetector. PN stands for photodetector. PN photodetector, PIN photodetector, second one. And the third one is APD, avalanche photodiode. We study about this APD, PIN and all these things, avalanche multiplication in EDC also. In EDC we know about this operation, how it is performed to have avalanche multiplication, and PIN photodetector and PIN photodetector we study in the classroom. Now, next one is called as your third point, see, modulation. Modulation का reverse क्या है? Demodulation. What the demodulation is doing? Reverse operation, which is called here as not a demodulation. We call it as signal restorer. It is called as signal restorer we are having. If you have a confused, you can also write this as a simply as your demodulation also. So, this is completely what the block diagram is present. The simple block diagram of optical communication system. I hope everybody in the class understood that. So, what are the light sources? I wrote in the syllabus is nothing but we study about these two types of light sources. And what are the light detectors or photodetectors we study in the classroom? We study about these three things, bhaiya, in the classroom. So, hope you understood this. Please copy it. Once copying is completed, please put a message. Sagar, I can explain in the classroom how we can find out when the cable is damaged. I can explain in the class. It's a part of our syllabus only. I can just explain to you how you can find out the damaged cable. So, we are in the basics part, na? Just it takes some time for us to understand all those things. Components, all those things are required. It takes some time. Once copying is completed, please put a message. Vishwa, intensity modulation is nothing but the light intensity is changing according to the input bit. For bit 1, the light source is on. For bit 0, the light source is off. on and off, the light intensity is changing or not. That is called intensity modulation. Okay. See here, it indicates for bit 1, your light source is on. It indicates for bit 0, your light source is off. When your light source is off, it's very simple, such that whatever the light source it is present here, which is off, is called as there is no light source, there is no intensity, but here intensity is high. What the intensity present here is very, very high. Hope it's clear. That's called intensity modulation. Yeah, class up to 10, and you can expect a break at 8 o'clock for 50 minutes of break for having your dinner or maybe supper. 50 minutes break I will give it to you at 8 o'clock. 6 o'clock I will start the class. At 8 o'clock you can expect a break of 15 minutes, and from 8:15 onwards I will start the class. So you can continue up to 10 o'clock. Okay, please. Right. So I got a message from the students about copying. I hope everybody copied this. I can explain the next part. So please concentrate here. Elements of optical communication system. Elements of optical communication system, OC. Elements of optical communication systems. So whenever we are writing about the elements of optical communication system, please see the block diagram by all of you. The input we are giving is the electrical input, and that electrical input was passing through a drive circuit. It is called as drive circuit. The drive circuit will perform one important task. I am writing here itself only, that is called as voltage to current conversion. Voltage to current conversion. So the most important task that performed by this drive circuit is voltage to current conversion we are having. The input we are giving is already which input? Electrical input. Very good. Electrical input. And that drive circuit will convert that into a current, into the current I. And the output of that drive circuit is passing through the light source. Already I explained to you, Bhaiya, there are two types of light sources here. Your light source will convert this current into optical signal. That current converts into an optical signal we are having. The amount of current that comes in front of your light source will convert them into the photons. We can tell in this way also. The number of electrons that are present here converts into photon. They are converted into photon we are having. So scholars convert them into the photon. Now just concentrate here one more point. Whenever we talk about a light source, already I told to you such that it is connected to a optical fiber cable. Up to here there is no doubt regarding the concept. So these two blocks, what are the two blocks we are having? Just observe it using this color. I think it should be visible to you clearly. These two blocks are combined to called as your transmitter. These two blocks, if you observe clearly, these two blocks are combined to called as your transmitter. That's what I studied about the transmitter we have. So observe this light source we are having, and that light source is going to be carrying the conversion of your current into optical signal. And those light sources are of two types. Already we studied. One is LED, other one is which one? Laser. LED and laser. So this is the block diagram. Internally, what are the components that are present in transmitter? I am drawing here. Okay. Now just observe one more point by here. This device. See, observe this one. This device. What's the recognized block here? See, this one is called as connector. It is called as connector. Okay. What's the connector is doing? The connector is making a temporary connection between, see, connector making a temporary connection between your light source and fiber. Making a temporary connection between light source and fiber. It's clear by a temporary connection, not permanent. See, writing in bracket, it is temporary connection. It is temporary connection we are having. So, temporary connection maintained between the two light source and fiber, or between the fiber and fiber, is called as your temporary connection maintained is called as your connector. It is called as temporary connection maintained by the fiber. After this, it is passes through a splice. So, please concentrate by a, it's called a splice, not slice, it is a splice. So, slice is one of the mango fruit we are having, so mango juice it is, not slice by a, it is splice we are having. If you talk about the splice, splice will make a permanent connection between two fibers. See, these two fibers are connected permanently, between the two fibers are connected is called as splice. Like if you have, see this copper wire, what we generally do is, this copper wire is cut or break down, some breaking is done. So, what we will do, we will going to make it twist this wire, twist it like this and put some tape on this one, connection is formed. That is called how generally we can make a connection between two copper wires. But it is not the procedure that performed in an optical fiber cable, it is called as splicing. Splicing means connecting the two fibers. Connecting two fibers with each other is called as splicing. Okay. Splice always offers, see splice always offers permanent connection. It always offers a permanent connection. Permanent connection is formed. Okay. So, permanent connection is formed by the splice. So, permanent connection is formed by the splice. I hope everybody in the class understood this. This is called a permanent connection is formed by the splice. Splice is used to connect the two fibers by a. Out of the splice, we are passing to another device which is said to be called as the coupler. It is called as coupler we are having. It is the coupler device is present. So, which is as shown in the figure by a, it is a coupler. What the coupler will do is, coupler will distribute the signal, okay, between other networks, between the other networks. So, when we are having a coupler, what the coupler will do? Your coupler will going to be distribute that to the another networks also. So, try to understand this part. To make it clear the diagram, I am writing like I am drawing in this way. So, here we are going to be having a fiber, see of this fiber length, this is also a fiber of length, of some length we are having, and from we are using here a coupler. Bhaiya, observe the concept, simple concept it is, very simple, nothing is there. So, if the connector is using to connect this one, it is called as a coupler, the name itself indicates couples. It couples the power to multiple receivers. Instead of only one point to point, it will make multiple points, multiple point connections. So, now just observe it, it is having a connection here, one connection is giving like this, another one is passing through the other circuits or other receivers. Okay, other circuits or other receivers, it can send the same optical power to the other circuits also. So, here it is sending to other circuits, optical power. So, couplers are of two types we are having, and one is called T coupler, other one is called star coupler. We will see in the concepts, in the upcoming concepts, in the components we will discuss all those things. At the iteration part, I will explain all these things to you. Okay. Now, see here. After this coupler, we are going to passing this through a block called as repeater. One student asked in the doubts, sir, we need a booster because using for long distance means this repeater only called as your booster. Now, this is what called as repeater by a. Repeater is used to regenerate the signal to transmit it for long distances. Okay, so what the repeater main important task is? The main functionality of repeater is it regenerates the signal. What's the difference of amplification and regeneration? Amplification is also increase the strength of the signal. Regeneration also increase the strength of the signal. But on the other hand, amplification also increase the strength of the noise also. But regenerator removes the noise and increase only the signal strength. Amplification just boosts the signal. but regenerator will going to be generate the fresh copy of the original signal. So more the distance you are transmitting, the effect of noise will be removed off by the repeater and generates the signal, which is going to be having a very high amount of strength, signal strength, like regenerating process. So what's the good thing I want to tell to you here is, in simple words I want to tell to you here is, your regenerative repeater or a repeater will remove the noise and boost the signal, okay, boost the message signal or boost the modulated signal. But if you talk about the same thing with respect to the amplification, amplifier can boost the noise as well as the modulated signal. That's the difference, bhaiya. That's why in communication system, mostly in the channels we don't use the amplifiers, but we can mostly use the repeaters. Repeaters are used for transmitting signals or boost the signals for long distance and reducing the effect of noise. I hope everybody in the class understood this. So we have 3 types of repeaters, bhaiya. Those things in detail we will study in the classroom. And remember another important point, please concentrate on this also. Thoda dhyan se listen. If you talk about a repeater, your repeater is a device called as electronic device. Electronic device. Your repeater is an electronic device. I know students obviously studied about the repeaters in PCM, pulse code modulation in communication system, in digital communication system. In pulse code modulation also, for long distance of transmission with your baseband transmission, we use the repeaters. PCM, DPCM, DM, ADM, always use your repeaters. The repeater operation what we studied in the classroom in digital communication and the repeater operation what you are studying here in the optical communication, same. There is no change of that and here. But I can explain this concept to you once we go for the components. There I can definitely explain operation of how the repeater is going on and what the signals, how it repeats and all those things to you. So don't worry about that. So I will just explain the complete concept to you. It's electronic device. Please clear, Nana. I am expecting answers from your side. What are the input signal you are getting? All of you. What signal? What is the nature of this one? Optical or electrical? Optical. But this device is electrical. We need electrical signal. We need electrical signal. Why? Because it is required electrical inputs. Because it's electrical device which is going to be having electrical input is required, but what are the input you are getting is optical. So we need a conversion. What is the device used to convert your optical to electrical? Already studied in the classroom. Optical to electrical conversion is done with the help of, which one, Nana? With the help of optical receiver. Please see here, bhaiya. I explained to you already in the classroom. When you want to make a conversion from optical to electrical conversion, it is done with the help of your receiver. Optical receiver will convert optical to electrical. Clear na? Now see here. Now you got to have an electrical signal, bhaiya. Dekho bhaiya there. You have an electrical signal. So changing the color of the pen to identify it. Okay. See here. We have electrical signal. So this is having electrical signal. Electrical signal hai. Now electrical signal giving as to the electronics, it will going to be completely change and regenerate the signal and generates once again the electrical signal. But you want the conversion of electrical to again optical. Why? Cable will carry optical signals, bhaiya. Okay. So you want a electrical signal is required here. So what you are trying to doing here is, I am going to be writing the box which is called as your optical transmitter. Your optical transmitter will simply going to be converts your electrical to which part? Optical. Electrical to optical. Now ho gaya. Again optical signal will come and that optical signal is now passed into a channel. Now the channel will carry the signal. So like this, every time repeater is there, the repeater will remove that noise and generate the fresh copy of the signal, and that signal is going to be transmitted for the long distances. And this is the complete components, optical components that are present in the channel. So there are totally 4 components, bhaiya. You studied. First component hai connector, temporary connection hai. Second one is splice, permanent connection hai. Third one is coupler, couple the power to optical power to other networks also. Next one is repeater, removes the noise, regenerates, boost, used for long distance, bhaiya. Clear na? Okay, those are the 4 components we are using in our optical communication system. Don't worry about that in detail explanation. Each and every point I'll explain to you in the components of this part to you. Just draw the diagram in the notes neatly, and advantages, disadvantages, applications I explain to you. Okay, so I hope it's clear bhaiya. Now just observe it. It comes to the receiving section. So receiving section we are having here completely opposite. See, light source का opposite क्या है? Light detector है. Light detector का दूसरा नाम क्या है? Photo detector है. So very good भैया. So light detector and photo detector है. Present a signal like this. Now that output of light detector is given to the your amplifier. It's an amplification process to boost the signal strength, and this is what said to be called as the signal restorer. I told in the classroom we use a signal restorer. So signal restorer restore back to the original signal. The original signal nature is what signal bhaiya? Electrical output. It's called electrical output. What the photocurrent is doing? Photocurrent is converting optical to electrical. Photons into electrons. What is light source doing? Converting electrons into photons. Converting electrons into photons. This is completely about the light detector. What this stands for? A stands for which one? Amplifier. It is an amplifier, and how it works and what is the necessity of using that amplifier we will see in the our receiving section clearly. Okay, so this is the output we are having, electrical output. Dekho bhaiya, this block what we are having is completely said to be called as, this block is called as your receiver block. So this is called as the receiver block we are having. So I hope everybody in the class understood this one, and this is called as the block diagram or elements of optical communication system. So questions that ask from this are of 2 questions they will ask. The first question is, what is the drive circuit is doing? Voltage to current conversion bhaiya. Voltage to current conversion is the operation done by the drive circuit. The second question they ask is about this repeater. What the repeater operation is doing? Repeater is performing regeneration. Regeneration means once again getting the fresh copy of the original transmitted signal. Generating a fresh copy of the original transmitting signal is called as regeneration. I don't want to ask you about the types of light sources and the light detectors. Those I explained already to you in the previous topic only. So these are the questions that came from this one. It's very important for your mains, okay, because they ask you to draw the block diagram and explain the points regarding that. So by seeing each and every individual component we can write it, because the points for those will be observed by us in the coming concepts. Okay, so I can just make it to reduce the size so that you can draw this diagram. Okay, so hope it's so one is permanent connection and the other one is called as temporary connection we are having. So please copy this diagram and take a break, small break of 15 minutes break. Okay, we will see after the break. By it is 8:15. So please all of you assemble here by 8:30. Okay, right.